which of the following molecules, so which, well, ions have a positive charge? So we have hydrogen carbonate. So hydrogen carbonate looks like this, HCO3. Remember, carbonate is just one thing to remember. Carbonite would be CO2. Well, in very different scenarios, but point being is that carbonate is HCO3 and it just has hydrogen attached to it. B, ammonium, that is just NH4. C, sulfate, is just SO4. D, nitrate, is just NO3. And E, hydroxide, is OH. Now, these ones, I'm just kind of naming them because I'm very familiar with the chart, but exactly, it should tell you what sulfate, sulfite, all those things, like, you just have to remember them because you have to remember how many oxygens they are, because you never want that to trip you over. You want to be adding too little or too many oxygens, and it depends on the name, which should be shown on the cheat sheet, and be able to be able to name those. So with that though, now along with the sheet, it also tells you, funny enough, what type of charge it has, like whether it's plus or minus. But in this case, it's actually a way to figure it out. So HCO3, okay, if you just drew it out, it kind of looks like, I'm just kind of making this up as I go, because it's carbon, H, O, 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 okay. And in fact, actually, yeah, it just helps me visualize. But the point is here is that carbon, according to the periodic table, if you remember from before, 4 electrons. O3, that's 6 times 3, that's 18. And hydrogen is just one of them. So 1 plus 4 plus 18. Okay, so in total, that would be 23 electrons it has to account for. Okay, so if we did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Interesting. Let's make sure. Oh, I see why. I went a bit overboard. So remember that each bond counts as 2, okay? And we only want to fill in as much as we can. So in this case, we have 8 right now, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And now we notice that won't work. For it to be complete, the best thing for it carbon to do is that instead of doing that, forms one double bond here, because this CO3 looks actually quite complicated. So with that though, we notice that 23 isn't enough, so we need another electron for it to, in a sense, quote unquote, be full. And actually, there's a much easier way to do this. I don't know why I didn't think of this. Sorry about that. We just use numbers. So O likes to be -2, and hydrogen likes to be +1, and carbon likes to be +1. But in HCO3, the way it breaks down, so it's -2, so that'll be -6 in total. Carbon has to make up for that, but carbon can only go so much. Hydrogen is going to be the +1 here, so +1 minus 6. Carbon can only go up to +4 because it only has 4 valence electrons. So 1 plus 4, that's 5, minus 6. HCO3 is -1. Okay, that is how you solve that one. It's a little bit tricky because these numbers can seem a little bit arbitrary, but in terms of think of what they can offer and what they can take. Nitrogen, okay, that one can be +5 technically, okay, and hydrogen in this case, because nitrogen is very, very strange in this sense, it really likes giving away hydrogens or like quote unquote electrons. So hydrogen likes to, in this case, play the -1 team, so that's -4 here. So NH4 actually would be NH4 plus. These are some things you also have to memorize because they actually do tell you the charge right off the bat. Sodium can only give away 6. Remember, oxygen is -2, and there's 4 of them, so that's -8. So in this case, SO4 will be 2-. NO3, nitrogen can also just 5. Oxygen -2, so it's -6. Okay, so NO3 is actually a minus, at least it should be. And OH -2. Okay, hydrogen is +1, so it'll be OH minus. So sorry about the earlier part, but the summary is that once you have this breakdown, by kind of working through your charges, then you can figure out which one it is. And you notice that the only one it would be is ammonium. We could have just skipped to the part where we said that, oh, it's ammonium because we know what the names are, but this kind of charge distribution helps you figure out which one is actually the positive charge for the polyatomic ion. Now let's see. So exactly, this is correct, but it don't really explain how. But exactly, that's why I just wanted to break down in terms of the numbering in this case. Okay, and now